All right. Hello, everybody. A little bit earlier today. Um, Got to pick up my girlfriend from an event later this afternoon, so I thought I'd hop on a little earlier today and hang out with you guys for a few hours. And then if we have some time later this evening, I'll also hop back on. But today is January 26th, 2025, a Sunday, and we are back learning programming today, just computer science in general, with C in Harvard CS50X Week 3 algorithms. We are currently trying to tackle the Tideman problem that we left off on yesterday. We completed the plurality sort runoff already, and now we are on the last problem of the problem set, Tideman. So I will preface this, you guys. So after we got kind of stuck yesterday and decided to, move on to something else, I I did go ahead and continue on after the stream. It just stuck in my mind, and I tried some more things, and I prompted the duck a little bit on here, and I got some information and it helped me think about things. So I wanted to try to implement that here with you guys. So let's go ahead and just get some people rolling in here. All right, people rolling in here. Hey Ryan, yes, early today. Gotta pick up my girlfriend from at her work this afternoon, so I gotta allot some time for that. So, hello, Natty Sanis. Yeah, funny enough, I kind of just woke up. I stayed up late last night, really late last night, working on some leak code with Mahan, a fellow subscriber here. Shout out to Mahan. We were working on some leak code last night, just getting some one-on-one practice, and it was really insightful learning about array algorithms, two pointers, left and right, and stuff like that. So it was good to get that. But I also will say that I did work on this off stream yesterday. It stuck in my mind, and I was like, oh, I just can't get over the fact that we got stuck. And so I kind of prompted the duck a little bit on here yesterday, and I kind of it kind of made me think about things a little differently, and I really wasn't understanding what the actual preferences was in this problem. So the preferences, from my understanding now, right? We left off yesterday on the record preferences function here. And so what we have is we have some two-dimensional array, all right, two-dimensional matrix, where we are just housing candidate by candidate. So candidate 0 would be here, candidate 1, candidate 2, candidate 3, candidate 0 would be here, candidate 1, candidate 2, candidate 3, right? And so if this is the 0, 1, 2, 3, this is the 0, 1, 2, 3. We say that this is the I, and then this is the J, right? So from this understanding is that we never want to land on where the candidate is equal to the same candidate, because that really doesn't tell us anything, because we're kind of trying to compare the ranking between each candidate, and decide, does this candidate win against each candidate, yes or no, right? It's kind of like a permutations almost of in a sense. So we want to we always want to start J at uh, I plus 1, right? So if I initially starts off at 0, J is going to start off, right, at J is actually going to equal I plus 1. Because we don't, like we said, we don't want to ever have a circumstance where we land on these, this, or this, right? We don't want to land, we want these to be, not found, like these are just kind of void almost in our data set. And so by having j plus 1, well, in each case, we'll scan here, we'll scan here, we'll scan here. In the next loop, we'll go up to I plus 1 and scan here, here, and here for j. And then here, here, and here, and here, here, and here. So that's essentially the effect that's going on. So if j is 3, I is 3, j is. Well, if j is I plus 1, if I becomes 3, j becomes 4, actually. Hey Mahan, welcome in. Did you even sleep, man? My guy, you were up late. Um, all right. So I equals 0. So my implementation I did yesterday, I have a little screenshot of it off to the side, is that with this understanding of how the candidate count is, well, I is 3, j still needs to go from 0 to I. So if I is 0, you go of the candidate count. Okay, so if we go like this in our function here, for record preferences, what I came up with yesterday was this. For int I equals 0, I then said that I is going to traverse the entire length of the candidate count. Right? We're going to increase I. Right? That's gonna increase I all the way through the length of the candidate count. Right? Dot 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 dot. We then need to prompt j to loop as well. For int j equals 0. So this is where I say j equals I plus 1. For j equals I plus 1. So what is going to happen on each iteration through this loop? Let me go back here. Matrix here. So if j equals I plus 1, on each loop, I equals 0. So we're going to scan j equals I plus 1 here. Okay, we're going to scan here. We're then going to go for the entire candidate count. So then it's going to j is going to continue increasing. It's starting at I plus 1 and going forward. So boom, boom. It checks those boxes all the way forward. Dot, 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 right? Now we shift over to I equals 1 on this outer for loop here, right? I equals 1 on this outer for loop. J equals I plus 1, so j equals 2. We're checking this spot. And we're checking this spot, and so on and so on and so on. In candidate 2, why are we not checking candidate 1 and 0? Oh, because we already are right here. Ah, okay, so we're doing j equals I plus 1 because of the fact that we don't need to do we only need to, technically we can divide. What we're doing is we're dividing all of this in half, basically. If you look at this, this is creating a pyramid structure, which will, in theory, is half of a square. So it's just n divided by 2 almost, or yeah, I guess. Data, yeah, the data divided by 2. Well, this is data squared almost. So n squared divided by 2. Um, something like that. So then on the next iteration at 2 for I in the outer loop, j becomes plus 1, so that becomes 3 here, so on, so on. And then obviously there, so on. Perfect. Get out of here. Right, so that's what's happening because we already are checking C0 and C1 right here. So we don't need to check C0 and C1 in this point. We don't need to do that because it's already taken care of in this matrix cell, the comparison of C1 to C0. So we don't need to do it vice versa because that's just kind of redundant. Um, perfect. Um, Woke up at 2 p.m. Yeah, I just woke up too about 30 minutes ago. Took my dog on a walk, and about an hour ago, took my dog on about a half-hour walk, got some breakfast, and then I hopped on stream here. um, hey Tim, how's it going? Did you forgot the three-sum we didn't try the three-sum yesterday. I'll show you the ones that we tried last night and we completed. We did 3 problems last night, me and Mahan. So shout out you, Mahan. Muna, hello, welcome. We're on week 3 algorithms right now. We solved all of the required problems, plurality, sort, and runoff. We're just doing the optional extra hard problem, Tide Man, right now. I've showed my dog on stream a couple of times. I've held her up here for it. I can do it again here. She's just sleeping after her walk over there. My kitty is too. Let me see if I can grab the kitty. She's not gonna like this. This is the little Miss Kitty lady. Woo, look at her. She's so cute. She does not like that. There you go, a little special feature. She did not like that. She's very timid, and I rescued her, so she's was feral at one point, and so she's come a long, long way. Okay, so exactly. So j equals I plus 1. We're gonna iterate over the candidate count while candidate count is less than j. And we'll increase j each time. So at this point in time, we're going to do the comparison, right? We need to make like instead of doing check marks here at each of these points, right? So these are the point we're going to tally basically the vote count at each of these points. So let me go ahead in my different color here. I'll make this a little bit bigger. So these are the squares that we're going to be filling in for data underneath in green, right? So we're basically tallying the amount of votes, right? So a vote equals a tally. So we're going to access the preferences matrix that we're in right now at preferences, right? We're provided the ranks of this single individual. So we need to, and the ranks mimics, right, the kind of the preferences in a sense with I and J based on the implementations before, right? We provide a rank of the candidate. So we can access the preference of ranks index I ranks index j, and then set this plus plus basically. So we're going to access for this candidate specific ranks, right? It's in order. That's the thing here is right. It's in order. So the rank the ranks is in order. So the single array tells us two things. A, the preferred candidate, and the preferred candidate in relation to every other candidate. So that's why we're able to mimic this happening. So the in the ranks, the zero index candidate that this specific voter had as their top candidate has precedent over every other candidate from J forward. So their C0, right, their top candidate in their ranks array has precedent over every other candidate from C1 forward. So we would go ahead and you increase here this count by 1 each time, because in the preferences array it's just max. We want to increase the vote count, right? Because the preferences is the mass data of all of the voters' ranks, combined, from my understanding. So we will go ahead and say that we got a vote here, right? Now, yeah, I think that's basically just it for that one. What keyboard and mouse do you use? I just use the Apple Magic Mouse and keyboard. It's not that great, honestly. I'm hoping when the stream kind of brings in a little bit of cash flow here to maybe upgrade the setup a little bit, but I kind of want to wait until the stream is able to do it itself. I think that'd be a good goal. We're not there yet, which is fine. It's not the point of this. Okay, so then we add the add pairs function now. So that takes care of this. So we add a vote at that preference, right? So now we're on the add pairs function. This function should add all pairs of candidates where one candidate is preferred to the pairs array. A pair of candidates who are tied, one is not preferred over the other, should not be added to the array. So if you remember, we had a structure called pairs. So what we need to do is we need to do a similar iteration over the preferences, right? We need to evaluate the preferences. So we have to do a loop over I and J again, similar to what we did before. So I'm just going to take this here. But instead of increasing that, we're not setting preferences, recording preferences, we're adding pairs off of these preferences. So we need to say if preferences at rank index I, but it's not ranks, we're not passing in ranks anymore, we've already set them, so it'd just be index I and J. And what are we comparing it to? Well, we want to make sure that this candidate in pairs, right, we have a winner and a loser. So we want to make sure that this candidate at this position is the preferred candidate over the other and make the pair, right? So that means that we'll have to have a new pair variable that is generated for each I index, right? Because we create a pair for every I index that is in relation to J. That's how we get that that effect that we have in the whiteboard of that reduction effect, kind of. So then we say new pair is equal to, this needs to have the pair constructor type out front, and this is just empty, so it's just nothing. We just create the new pair on each iteration of I. And then we compare if this is greater than preferences index Ji, right? So we want to make sure that this candidate is preferred over the other candidate of J at that position, right? And then if that's the case, right, we need to identify in our new pair the winner is equal to the I and the loser is equal to the J candidate. So new pair dot winner is equal to candidate I, and new pair dot loser is equal to candidate J, right, on this axis, right? The candidate is directly proportional to I and J, right? On these, J is just +1, so you don't overlap candidates. And then you need to increase the pair count, right? That's global. And then you need to add this pair to the pair array, right? So before we increase the pair count, right, we need to add this pair at the current open place. So then we'll say pairs array that we have, right? It's called pairs. Yeah. Pair count is equal to the new pair. Right. So the pair count will increase for every new pair that's generated after each loop, and so we'll have a new place for that pair to go upon each new creation, right? So I believe this is the function I came up with yesterday for the add pairs function. Because preferences, so Mahan, you said 121. Preferences is an integer. The number of votes who prefer I over J. So you need to increase the vote count at that point by 1. That's why I did it like that. Okay. So now we're on these couple of functions here. Oh boy. Now that's where I stopped yesterday. So the sort pairs function. Oh boy. Add pairs. So the function should update the global variable pair count to the number of pairs and candidates. The pairs should thus all be stored between pairs index 0 and pair count -1. Let me see here. Oh, whoops. No way. I might pick here. So you say, isn't it preferences ranks? No, because you're not passing in ranks on this individual. You already recorded the ranks of all the preference. You recorded their preference for every integer for each ranks. And it's called in the notes here that this function record preferences is called for every person's rank. Because if you go back up here, record preferences is nested in here for every rank, every candidate, for every voter. So you already handle that here, and then you just add the pairs from the finalized preferences. What? The index you wrote in line 121. Isn't it preferences ranks I ranks J? Oh yeah, like that. Cool. So now we're on the sort pairs function. So now we need to the function should sort the pairs array in decreasing order of strength of victory, where strength of victory is defined by the number of voters who preferred the candidate. If multiple pairs have the same strength of victory, you may assume that the order doesn't matter. So sort pairs. What do we need to do here? So we can use the thing is the candidate count can't go beyond 9. So it's not like we have a huge data set. So inserting some, fast algorithm for sort might not be super viable here just because the data set is constantly small. So I think we can get by with just using like a selection sort or something like that. What do you guys think? Do you find the Magic Mouse ergonomic? I heard it really goes well with Mac OS. Honestly, I've just had, um, I gave it a really fair shot. I've kind of just had poor experiences with it. I, it's just not very responsive. It has, it's pretty, not as responsive as other mouses I've used. The touch, I miss the scroll bar, the scroll wheel, because I constantly find myself, I miss the two buttons. I don't like, yeah, I just think it's just not all there. All right. So, what do you guys think about using selection sort or something for this? So the thing is, the function should sort the pairs array in decreasing order of strength of victory. So our pairs array is just a basic array, right, that is half the size of the max number of candidates, basically, whether it's even or odd. No, the pairs array is not half the size. It's a multiple of the size. So it's like if it's 5 times 4, 20 divided by 2 is 10. So that's double the array size. If it's 10 times 9, it's 90 divided by 2, 45 pairs for 10 candidates. But you can only have max 9 candidates. So 9 times 8, 72 divided by 2. Oh boy, what is that? 36? Yeah, so you can have 36 pairs with 9 candidates. max pairs. But I guess the pair count is really what determines it. This just pre-allots. Okay. So sort pairs. What is our goal here? So our pairs array So we have a pairs array which house objects of pairs. Pair 0, pair 1, pair 2, ... right? That being said, each pair houses a winner and a loser. We want to sort these pairs in order of decreasing strength of victory. So we want to know the difference in strength between winner and loser, right? And then between all of the pairs, and then sort them that way. So we'll go through, iterate through the array, determine the lowest, the index with the lowest, or the position, right, in the array with the lowest in decreasing, so the highest will be at the top. Decreasing strength, so the lowest margin, basically, will go at the bottom. Right? So in sort pairs, for int I equals 0 over the pair count greater than I plus plus. So we're going to go over the entire pair count, right? Which is, and then we're access the pairs array. We're going to have smallest pair smallest is just out front, like so. And we'll set the smallest immediately so smallest needs to be immediately set to equal pairs at index 0, right off the jump. That means we need to iterate over I at index 1 first, because we don't need to do a comparison at index 0. So for I, iterate over the pair count. So with selection sort, do we use two for loops, I and j, nested together? We gather the smallest over the initial. So if pairs at index I what are we trying to compare here? The margin, right? So the winner votes. So pairs index I houses an object which is a pair, which has an attribute of a winner and a loser. Winner oh boy. Oh boy, oh boy. So the pairs array houses pair objects, pair structures, pair objects, right? Each pair object houses a pointer to a candidate that has a winner and a loser. So you have int winner, int loser in the structure, but I point so I assign though the winner to I and J, so an index on the candidates array. So it's an index to the candidates array as the winner and loser. So in the first pair we have, which is C0 and C1, candidate 0 and candidate 1. If the pair index I oh, I'm just not getting this on the sort pairs part. So if pairs at index I is okay, hold on, let's go over this again. We have the smallest, which happens to be pair 0. So it wouldn't be the pair 0. Pair 0, well, what is the margin? The votes and preferences for so pairs 0 gives you the pair, the houses winner and loser dot winner. Pair 0 dot winner is the index to the candidate preferences of this index pairs with a 0 winner. So we would have to blanket stuck. Okay. So let's not deal with the smallest right now. Let's think here. So we're iterating over all the pair count. We're accessing each pair. So we're first getting the 0 index pair here. What do we want to evaluate at this 0 index pair? We want to get the winner here, which is also an integer, for the preferences array. So this will give us the winner, the preferred candidate, over if preferences if that is greater than preferences pairs index I dot loser pairs dot winner. So if it is great, if the margin is greater so it would need to be less than. So if the margin for the winner to loser at this current preference is less than the margin Anybody have any ideas? Am I on the right track here? Debugger. I am having trouble with the sort pairs function. I am trying to implement a selection sort for this function. For implementing a selection sort, you need to repeatedly find the minimum element from the unsorted part and move it to the beginning. Can you show me the code you have so far? Yeah, I'll show you that. Sure, why not? It looks like you're starting to implement a selection sort, but your code is incomplete. To help you get started, loop through each element in the array, find the smallest element in the unsorted part of the array, swap it with the first element of the unsorted part. Find the smallest element in the unsorted array. With selection sort, do we need 2 for loops that are nested? So the smallest okay. So let's just find the magnitude int magnitude is equal to preferences index through. Yeah, we'll need 2 for loops though. So let me see. Bring this over. In selection sort, do you need 2 for loops? Yes. Okay, so for int j equals I plus 1 pair count greater than j, j plus plus. Okay, what do we want to do at this point? So we're accessing every pair, basically, which houses a winner and a loser, which is an index over them associated to the preferences. So we do need to reference the preferences to access the magnitude. So int mag1 is equal to preferences index. What do we want to put in these indexes? We want to put so we'll go to the first value, the first thing. We're going to iterate then over all the other ones and find. So we need to find a magnitude of I here at this step, right? So mag1 is going to be equal to preferences. Oh no, I guess we have to do it in this because we need access to j. So it would stay here. So obviously this is going to be some I and some j here, but we're not accessing the pair at index I and the pairs at index j, right? And so we're not accessing, so that gives us just a winner and a pair object. Then we need to access the dot winner here and the dot loser here. So that gives us magnitude of 1. And so if we bring this down and make this preferences winner of j now, and I here, this is going to be magnitude 2, right? We want to say if magnitude 1 is greater than magnitude 2, meaning that So we want to do the swap if magnitude 1 is less than no, if magnitude this is tough. So if the magnitude difference between these two pairs, winner and loser preference. So if magnitude 2 needs to be greater than magnitude 1 in order to do no. Right, we want to make sure that if the J winner is greater, so magnitude is less than mag 1. No. So our left pointer is basically magnitude 1. Our right pointer is magnitude 2. We're moving into the array, and we're searching through all the other ones for preference. If we find a smaller one, if we find one that's, if magnitude 1, it happens to be smaller than magnitude 2, we need to swap magnitude. Okay. So if magnitude 2, if mag 1 is smaller than magnitude 2, then we need to swap positions in the array. Of pairs. Oh gosh. So pairs index we need to swap I with J. Pairs index I pairs index J equals pairs index J pairs index I. Oh boy, I don't even know if I'm anywhere close here. It looks like you're right on track. Okay, but there are a few issues to address. The inner loop should start from I plus 1, not 1 plus I. Okay, so I plus 1, sorry. The swap operation is not correct in C. Can you try to fix these issues and show me your updated code? Okay. So, how could I do this swap in C then? So if pair I has a magnitude as a preference that happens to be lower than than the inverse of that preference pair. Do the swap. So we need a temporary variable. So pair I would equal temp is equal to pairs I. Um, Pairs J becomes equal to temp, and pairs I becomes equal to no. We need to save the pairs J is equal to temp, pairs I is equal to pairs J. Is equal to temp, and then pairs. No, because we need to save pairs J is equal to pairs I. But that won't work because pairs I is now equal to temp, which was pairs J originally. So we make this pairs I is temp, pairs J equal to pairs I becomes equal to pairs J. But we need to have previously saved pairs J so we don't override. Oh yeah, like that. Hey, Christmas, how's it going? Tomorrow's my Amazon SD1 interview. Congrats, man. Any tips? Um, for me specifically, not too many. I never interviewed for a software engineering position, so good luck on you, man. I've only done just, chemistry and stuff positions, so honestly, the best advice I can give with interviews is um, if you if there there's no point really in stressing like when push comes to shove because if they ask you a question you don't know you just don't know it, right? So like what's really the point of stressing and trying to predict questions you may not know when you don't know what questions they're going to ask you in the first place. So you can only be as prepared as the information you're given. So honestly, the best advice I think I can give is just to try to be yourself and convey like authenticity. I think that with interviews, people try to be something that they're not, and it's easy to see through, and you kind of lose the ability to relate to the candidate and be humane with them. So whenever at least for when I've been on panels to do interviews for chemists and stuff, like junior chemists, I really like to find someone that, is just like a normal person, honestly, that isn't trying too hard to convey this personality that really probably isn't even them. When after some amount of time that fades that away, like right, I try to convey your true colors up front. So we save temp to pairs I, we save pairs I to J, and then override pairs J with temp. So pairs I is saved as temp, it's overridden as J, and then we save J as temp here. Like that. I think that's it right there. So this is what I got. Looks like you're almost there. There's a small, oh, we just need a, yeah, for those that don't know, I'm actually a chemist by trade. I've been teaching myself software engineering just in my own free time out of my own free will for the past, half a year. And so we're currently taking Harvard CS50X to get some introductory into C and general computer science topics and full stack development. So but I've been mainly focusing on Python, and I've been creating projects and doing a lot of DSA learning in Python and whatnot. So thanks so much for coming in. Yeah, so I can kind of convey just general tips for interviewing in a professional environment, but not really for a software engineer. Now, there's a lot of people that are software engineers, like I know like Coding Mountain Man, and they might have some tips in the chat if they're here. Okay, so I'm gonna go like that. This is my code here. There's a logical issue with the comparison. You should be comparing the victory strength, not the preferences directly. Consider comparing the difference in preferences between the winner and loser for each pair. You should be comparing the strength of victory, not the preferences directly. Okay, so magnitude 1 minus magnitude 2. Mag 1 minus mag 2. Instead of comparing mag 1 and mag 2, you should compare the strength of victory directly. Try comparing to help you determine which pair has a stronger victory. Can you update your comparison accordingly? Try comparing preferences pair J dot winner, preferences pair J dot loser, and that's what I'm doing. So I guess we'll get rid of this and say if like that. That's pretty much the exact same thing. It looks like there's a small syntax error in your comparison. The closing bracket is missing. Oh. However, you might want to make sure that you're ensuring. Okay, so if the so we just need to flip our sign here. And that does it. The debugger's kind of goated here. Can you show me some code that implements my previous advice before asking for it? I did. I flipped the sign. I flipped the sign. If you sort the pairs correctly by the strength of the victory, if you encounter any issues, let me know. Okay. So, I think that that's it. You guys, is that it? So, we're evaluating preferences, pairs I winner, loser, if it's greater than. But what does smallest have to do with anything? Do we even need it? When running down the problem, yeah, for sure. Um, Pairs I dot winner. So if we were to preferences pairs J winner pairs J loser. Pairs J. So there's like a comparison here. So we're accessing pairs index I winner and pairs index J. So, oh, okay, I see the problem here. Is that we are not evaluating the same pairs condition at each point. Why are we doing I and J? This needs to be, if the J one is greater than the I one winner, than the I one, right, then we'll do the swap, like so. I think that that is the correct way to go about it. Your code looks good. Now test it. See if you can sort the pairs correctly. If you encounter any issues, let me know. Okay, cool. Right, because we're comparing the pair J, which is the pair one further, one right here. This is pair J. This is pair I here. So if pair J's winner-loser ratio is greater than pair I, then we need to swap them because pair J will come first. Okay, sweet. I think that that is correct. Hopefully. Lock pairs function. Complete the lock pairs function. The function should create the locked graph, adding all edges in decreasing order of victory string so long as the edge would not create a cycle. Oh boy. What? Locked pairs? A locked graph, adding all edges in decreasing order of victory string so long as the edge would not create a cycle. So do I need to create like a linked list here, like my own structure? Do you need to create your own struct for the lock pairs function? No, you don't need to create your own structure for locked pairs. You can do it using the existing pairs array and locked 2D array implemented into the function. Oh, there's a 2D locked array? Oh, there is a locked array, which is I is locked in over J. Candidate I is locked in over J. So for lock, we'll have to go for int I equals 0 over pair count. Well, pod count is greater than I, continually increase I by 1. Right? And then for int j equals I plus 1 to pair count greater than j plus plus, right? If pair at index I so that the edges would not create a cycle. So I can loop over I and yes, you can loop over the pair count using nj plus 1 to compare the lock pairs. Just make sure to check for cycles when locking pairs to maintain graph's acyclic property. I am not sure what you mean by checking cycles. Checking for cycles means ensuring that adding a new edge, locking a pair, does not create a loop in the graph. This is important to maintain the direct acyclic graph property. To check for cycles, you can use a recursive function to see if there's a path from the loser of the current pair back to the winner. If a path exists, adding the edge would create a cycle, and you should not lock that pair. What? Oh. So we are cooked, right, Tim? Are we cooked? So understand the locked array. Locked I and j is equals true means there is a direct edge from candidate I to candidate j in the graph. Before locking a pair, you need to check whether adding an edge from pairs I to winner Okay, so we iterate over the pairs. We'll go locked pair at index I so we're creating a new matrix, basically locking the pairs together. So what functions do we have here? I don't know. Are we cooked here, boys? Are we cooked here? It's not looking good for us. Not looking good. Okay. So we'll say this is what I have so far. To check for cycles, you can use a helper function. Here's a general idea. Create a helper function, check for cycles, and lock pairs before locking a pair. Use a helper function. We're not supposed to modify anything else. To avoid creating cycles, you can use the recursive function to check if locking a pair would create a cycle. Here's a general. Loop through each pair. Before locking a pair, check if locking it would create a cycle. If it doesn't create a pair, lock the pair. So we'll say for I, for I, so it'd be like if so if pairs index I dot winner is equal to pairs index I dot loser, right, return true. Right, else we need to, so that would be our base case, where if the winner equals the loser, if the pair's winner and points to the loser, you can't so we got this so far. Can you think of a way to first check that there's a path from the loser back to the winner? Oh my gosh, this one's tough. So what would be our base case in this recursive approach? I don't know what would be our base case. For the base case, you can check if the current node is the same as the starting node. This is so annoying. Can you check if the current node candidate Yeah, Tim, we're cooked here. Recursively, I can winner. I don't know what to do for this function at all. This is probably boring. The function should create the locked graph adding all edges in decreasing order of strength of victory, so long as the edge would not create a cycle. So we obviously need to iterate over I, the pair count. We can access so if you access pair index I, that gives you the highest ranked pair. The highest strength pair. So if the winner so the winner can't point the winner here so the winner of the last pair in the sorted pairs array cannot be the winner of the first pair. To avoid cycles, you need to ensure that adding a new edge does not create a path back to the starting node. Can you try implementing a recursive function to check if there's already a path from the loser to the winner? Can you try implementing a recursive function to check if there is already a path from the loser to the winner? GG, yeah, right. So this is what I have so far. You didn't give me any advice. You just told me the same thing over and over again. Can you try implementing a helper function? We are not supposed to change anything else. Let's focus on locking pairs, on the lock pairs function itself. To avoid creating cycles, you can use a recursive function to check if locking a pair would create a cycle. Loop through each pair. Before locking a pair, check if locking it would create a cycle. If it doesn't create a cycle, lock the pair. Okay, so we loop through each pair. Before locking a pair, check if locking it would create a cycle. So if the winner you can recursively call a function if it's void. Hey Manny, we're on week 3 algorithms right now. We're trying to solve the Tide Man problem, but we're struggling through it here. I'm having difficulty locking pairs. I am not sure where to call the function again, and it is void for a param. Can you show me some code that implements? You didn't give me any daggum advice. Didn't give me any advice, you piece of crap. You just told me the same thing over and over again. Yeah, like how do you tell if a cycle will occur, right? Because the pair, all the pair has in it is a winner and a loser. So we just need to, I guess the recursive, we need to break it down onto each pair. Yeah. Come on. So, do we need to recursively break down until we have a single pair? Hmm. Maybe iterate going down the chain from winners to losers. And if you end up where you started, it's a cycle. What do you mean by that? So how can you tell? So if I go down, I go to the pair index. So in my example here, if I have pairs and some array of pairs P0, P1, P2, right? Each pair has a winner and a loser. So then what would point cyclically here? Maybe iterate going down the chain from winners to losers. Ugh. What is locked as a boolean? True and false. A cycle in a directed graph means you can start at one candidate, and by following directed edges, you can return to the same candidate. Imagine if we're looking at candidates A, B, C. If we lock the following pairs, A points to B, B points to C, and C points to A. We're starting from A, and you can follow the arrows. A points back, C points back to A. Oh, the loser is the next pointer in a linked list. So the loser is the next pointer. Oh. Oh, okay. That's what's happening is the loser of the previous round is the winner of the next pair. So the loser of the current pair is the winner of the next pair in the iteration. To avoid cycles, you need to check if there's already a path. If pairs dot winner pairs at index I dot winner is equal to loser, So from the loser to the winner before locking the pair. So if the current pair loser equals to I pairs index 0 dot winner, will you return false here? Got to keep track of the ith pair on each iteration. Can you explain that, Seslo? I always suck at understanding the ith thing. I suck at that stuff. So let's take this and see what it says here. It looks like you're trying to check if the cycle, instead of returning false, you should continue checking other pairs. Also, you need to lock pairs if it doesn't create a cycle. Instead of returning false, you should continue checking other pairs. So if it doesn't equal the winner, we're going to set it. Also, you need to lock the pair. Locked. Is it locked pairs? Just locked. Locked at index I. Is equal to true. Like that. No idea. We're not supposed to use helper functions. We are not supposed to use helpers. Ugh. You're annoying. Gotta keep track of, okay, like in the for loop, you start at pairs index I and then go to the next pair, etc. I wrote my code space. Yeah, me too. I was struggling here. So if the locked pair locked I, so we need to access locked because the locked has is a matrix, right? So it has to be pairs index I pairs index j equals to true on this evaluation. But if it is equal to I don't know. And this thing sucks. Dot winner and dot loser. Dot loser. Locked pairs I winner loser equals to true on this check. Oh my god. I don't know. This is annoying. Like, this isn't even helping me anymore, like, learn. This is just like. This isn't even helping me learn anymore. It's just like beyond my scope. Honestly, don't even feel like this problem really helps people learn in general. I think it's just kind of too out of reach. But you need to ensure that locking a pair doesn't create a cycle. Well, can you explain how you plan to create a cycle? Well, I can't. You're restoring stamina. Treat pairs I as the start of a linked list. Okay, so it's like the head. So if the head pairs I dot loser equals then go down the list until you reach pairs I again. I'm sorry, Lo, I really am not following. Then go down the list until you reach pairs index I again. Where would you become circular here? Hey, Comp Sci Wizard. Appreciate your comment here. Unfortunately, though, we haven't quite got to depth first search or whatever, depth, whatever, I can't remember, in the class yet. We are currently bound by some of the limitations of what's been taught in the lecture. But yeah, I bet you that's probably a good approach. I don't get how. So we're iterating over the pairs, right? We are going. We have these pairs in a list here, right? We are going one pair, each pair to pair. If the loser of another node is the pair's I winner, it's a cycle. So we'll say if the loser of another node, what do you mean another node? If pairs I dot loser is equal to what is the return value of each pair? Each pair just houses a node of a winner and a loser. So then slow, how would I set this up in terms of a base case for like recursion? Because it keeps prompting me to try to use recursion, and I just suck at recursion. I just can't. I just suck at it. It's just um I just don't get what we're doing. Like what are we doing? Like why are we going through all of this like it just seems so tedious. Like why are we even doing this? Like if pairs I well, the pairs at that current iteration is never going to equal. So this is wrong. uh, so you want me to use another for loop here for J? Right? Okay, so now we got another for loop for J in here. So now we can access the locked looks like you're trying to lock pairs, but you need to ensure that locking a pair doesn't create a cycle. Can you explain how to do a check for cycles in your current approach? So if if so if it looks like you're trying to lock pairs, but you need to ensure that locking a pair doesn't create a cycle. So if the okay, I have that. Looks like you're trying to avoid cycles, but the logic might need some adjustments. Instead of checking pairs index I dot winner equals a pairs J a loser, you should check if locking the current pair would create a cycle. Can you think of a way to trace back from the current loser to see if you can reach the current winner? This would help determine if a cycle is formed. So this is where I was talking about recursion. Anyone have any thoughts? Maybe prayers? Oh my gosh. Struggling, dude. I'm not having fun anymore. Not having fun. Okay. A while loop inside of the for loop. Right here. What do I say inside the while loop low? At line 176. Wow. Hey Levi Richardson, how's it going? Welcome in. If the parts I winner the for loop is for the pair that'll be the start of the graph slash list. While pair Hey Levi, so our goal here is we're trying to, I honestly don't even know, like, we're trying to, we have sorted pairs now in a pairs array that have pointers to a winner and a loser. And we're trying to, looks like you're trying to avoid cycles, but logic might need some adjustments. Instead of checking if, should check if locking the current pair would create a cycle. I don't know how to use recursion. Create a function that checks adding new edges creates a cycle. The function should call itself recursively to trace back through the graph. Hey Tim, it's not going so hot here. Yeah, I don't know what to do. I do not. I don't even really know what's going on in the problem. I feel like that's our issue. I don't even know what's going on like here. Like the verbiage with edge and like it's just is it's really honestly quite vague and terrible. Why is int I set to 0? Here? Just to start from 0 in the pair count? I guess. I don't know. I honestly don't know. I'm struggling really bad with this. Oh boy. You guys got any tips for me here? Anybody got any insights? Calling a lifeline here. I can't figure this out. I'm gonna grab us something, some candy. I'm struggling. All right. Okay. In your pairs drawing, Each P would be the start of its own linked list. Okay. So should I keep my for loops? Sorry. Nerds got me chewing. So in your pairs drawing, each P would be the start of its own linked list. Okay. So then if each P is its own linked list, my problem is the locked pairs function doesn't take in any parameter. So it's not like I can pass in the current node I'm on. So how do I update the node for the next node? Like it wants me to call this recursively, right? That's what this is intended for. So if I can't pass anything into the function, I don't get how it's going to do anything. Right? So we start off with a P here. We say I equals 0, 1, 2. I and J starts here. In the debugger here, the debugger and everybody online says that there's a recursive element to this problem. And I'm pretty sure it's right here. Because if you're wanting me to use 2 nested for loops and then a while loop inside of that, and that's getting pretty inefficient. I don't know. The locked array represents a directed graph where locked index I and j equals true means that there's an edge from candidate I to j. Where locked index I equals true means that there's an edge from candidate I to j. So if there is an edge on the last candidate to the first candidate, then what? Set it to false. Yeah, I have to do it iteratively. Okay. Yeah, because I'm wondering why is this prompting me to do recursively if I have no input to the function? So I'm just getting confused here by the tool, like it's confusing me. It's trying to tell me to do it one way when it's literally like I can't. Okay, so what do we say then? We say is a directed graph where locked I and index j is equal to true means that there's an edge from candidate I to j. So what comes next after this for loop, basically? Right, after we access each I, after we gain access to I and j across pair count, I don't even know how to solve it in my drawing. That's the thing. Like I don't even know where to go from here. Like yeah, I don't even know where to go from here. So yeah. So P0. We access pair count of index 0, pairs of index 0, which is this guy here. We say this has a winner, this has a winner, and this has a loser, right? If this winner so if pairs at index I dot winner is equal to pairs index j dot loser, set this to false. Using recursion. Like, what do you mean using what? I'm not supposed to create any functions. I'm only supposed to modify. You should only modify Tideman. You should only vote, record pairs, add pairs, sort pairs, log pairs, print winner functions. You are not. You are permitted to add. Oh, you are permitted as long as you do not change declaration of any existing functions. And we'll say if not cycle of what? Pairs index I, pairs so then if cycle is cycle, so if not is cycle, so if is cycle returns true, set this to false, else set it to true. So we have my gosh, type is cycle 1. I wouldn't need the inner for loop. Why? I'm using J here and down here. So I got rid of this for loop. Move this back. If not is cycle given, is it I loser? I suck at recursion so bad. I do not get this at all. So we have an is cycle function which takes in the winner and the loser of the current pair. So then what does the is cycle need to do with those pairs? I don't really know what it needs to do with the pairs though, because how can you detect if this is going to be actually int winner, int loser, if winner if this is true, that's a false. Yeah, else says, yeah, right, okay. For if here's index 0 is equal to let's see here, let's take this. So we're not even using J here though. Oh my gosh, type. So I'm not even using this for loop though. It looks like your if cycle function is not complete. You need to check if there's a path from loser back to winner. Can you try adding a recursive call within the function to trace back to the graph? So what's our base case? So in the is cycle for loop, check if the loser is equal to the pair's index J winner. So pair's index J winner is equal to the loser's so your is cycle function needs to check if there's a path from the loser back to winner. You can do this using recursion. Can you try adding a recursive call within the function to trace back through the graph? For example, if there's a locked edge from the current loser to another candidate, else you call is cycle here on pairs J plus 1 pairs J plus 1 dot loser dot winner, like that. It looks like you're on the right track, but there are a few issues with this. That you need to return the value from the recursive call. You should check if there's a locked edge from the current loser to another candidate. I don't know what I'm doing. I feel like I'm just adding random crap. You need to check if there's a locked edge. Else return true. You need to check if there's a locked edge from the current loser to another candidate. You should return true if a cycle is detected. I feel so dumb. Specifically, you need to. I don't understand. Please break it down further. If the base. Oh, okay. What the heck? Did it just give it to me? Let's break this down step by step. Base case. If the loser is the same as the winner, a cycle is detected. Else, recursive case. Check if there's a locked edge from the current loser to another candidate. So, if loser equals winner, return true. Right off the bat. The base case would be if there's no pairs index j dot winner. So if the loser equals the winner, return true. For candidate and candidates. If I'm so done with this. I just want to be done with this week. We still have a whole nother function to go. The cycle is detected. Else, we'll iterate through, get the new winner. That's equal to the loser. or yeah, I'm right there with you, Lo. I appreciate you being here with me. We're solving this together here. So for each candidate in candidates, if there's a locked edge from loser to candidate, hmm. So if is cycle, return true here. Else we return false at the end of the loop if we don't get anything. You should only return true if a cycle is detected. If loser equals winner, return true. For int j all the way through pair count j plus plus. What did it do here? If locked, loser. If if locked, loser j, which represents the I loser, and then so if is cycle for winner, and j return true, true false. So what happened here? We have a base case is that the loser equals the winner given at this certain point, return true. So then print the source of the graph. So this will just print f the percent string \n of locked locked 0, 0. The function should print out the name of the candidate who is the source of the graph. The source of the graph. So if I want to print the candidate that is the source of the graph, right? So the source of the graph tells us what? How can we determine the source of the locked graph? Determine the source of the locked graph. You need to find the candidate with no edges pointing to them. So you can do this by checking each candidate to see if there are no true values in the column of the locked array. Okay, so I'll have to say int I equals 0. We're going to if we need to say for j I plus 1 pair count greater than j print f if not locked index I and index j print f locked index I. That'll tell you the locked is a true value, true or false. we don't want to print locked index I and J. We want to print pairs index I and J dot candidates. So the pairs so this has to be locked for I and J, which gives us a Boolean expression of true or false. So we actually don't want that. We want this on pairs, which gives us an integer for the winner. The candidate. Like that, I think. There's a few issues with your approach. Remember, the winner is the candidate with no edge pointing there. You try checking, you just can't see if there's true values in their column with a locked array. What do you think the code will look like? So if not locked, at I and every step of this J, print F. That's what I thought I was doing. Pair count. So it would just be, it would just be pairs at index I, because pairs is a single array. I think that's how it would be. Can you show me the code that checks for the candidates either? There are no true values. If locked, so if you get a false, do nothing. We're close. So if we get a false for locked, we want to print the winner at the end. of the for loop. Hey Parsa, thanks for coming in. I appreciate your kind words. I've been struggling this go around here, so only one for loop. The entire column for each candidate. And, and since they're sorted, the first one that's true is the winner. Well, the winner, it's saying, is the one that has no edge pointed to it. What line do I need to focus on? Focus on the logic that checks if the candidate has no incoming edges. Specifically, you need to check if each column in the locked array So we'll start on I, we'll go to the candidate, go down, it's locked, see if there's any trues. Ugh. You need to do this part here, right? So if you are locked, we'll break at this point. Else we'll print F here, the %S for this here. Like that. I thought I'm doing this. What do you, I have a loop going. Like, can you try implementing a loop that checks each column for true values and prints the candidate's name if no true is found? Is equal to true break. I swear I'm doing this, but I've been wrong. It looks like you're still working on the logic. Remember, you need to check each candidate to see if they have no incoming edges. What if we say like we set a flag for has edge if we get a locked, right? We set bool, or we set has edge equal to true. If has edge, print the function. You should be checking each candidate, not pairs. It says you should be checking each candidate in each column in the locked array. Looks like you should be checking each candidate, not pairs. Each candidate. Candidate. I'm gonna check every candidate. Like so. The loop should iterate over all candidates, not pairs. I don't even have pairs written in here anywhere else but here. So you're getting closer. Doesn't. So then this should be the candidate count, right? This is candidates index return like so. Stamina, come on. So it has edge. So I think, is that good? Lock JI. I hate this problem. I have no idea. I'm just literally using the debugger here to help me through it. It's just kind of like annoying to like have to go through and like fix stuff that's already done. I would much rather just make the whole thing from scratch so I can follow it from the whole way. But, you know, I guess that's not always how things are, right? But okay. So what happens here if I go make CD type? 118 candidate count. 120 candidates. Count. Yeah, starting from scratch. Yeah, I think my biggest problem with this problem was that I just didn't like having to like see what they did beforehand to see how it all works together. Like I think I would have learned a lot more having just actually done it myself, like given me instructions to write all the functions out myself. Like yeah, it would have been a lot of work, but like it just I didn't really like having to like deduce all the other crap that they already done. Like that in itself added like another hour and a half, 2 hours of just work trying to figure out what they did before. It really kind of, I don't know. I'm indifferent, I guess. Line 132, just a bunch of spelling errors. Line 135. Line 137. Line 137. Line 176 is cycle. We need the constructor for is cycle out front. $179. Oh, we're not accessing J here. So this is this cycle. I equals 0. X I X I. Okay, that did it. We're struggling, Ryan. Oh my gosh, this problem is ridiculous. It is crazy. We're struggling, Ryan. That's for sure. So, let's do / Tide Man with Alice, Bob, Charlie. Tide Man. Number of voters 5. Alice, Bob, Charlie. Alice, Bob, Charlie. Charlie. Okay, that's why. So let's just go. Let's just do the check 50, I guess. I don't know. Will we get it? No. Ah, no. Vote correctly sets rank for all preferences. Vote did not correctly set rank. Vote correctly sets rank for all preferences. Vote function did not correctly set ranks. I hate this so much. So done. Just like, this is taking all my like life away from wanting to program. Vote correctly sets ranks. So we do not set all ranks. It really can't count. Okay, name. Return true. So let's go over to my duck AI here. Throw that guy in there. See what it says. Trying to update the ranks for the candidates. However, you should be updating their ranks at the position. At the rank position with the candidate's index. So it should just be rank at index I. Okay. Check 50. Let's see what happens now. Okay, so now our add pairs function is wrong. Okay, so let's throw this in the debugger and see what it says. It looks like you're on the right track with adding paths. However, you should also handle the case where preferences JI is greater than to add. Can you try adding an else if condition to handle that case? Okay, so else if this greater than or is less than, right? And so in this case, we'll say we're almost there. Oh my gosh, I can feel it. Ah! We're almost there. Okay, so what needs to be done here? Um, hey, Alice Dominguez, how's it going? Welcome. How you doing tonight or today? How's it going? So LF preferences index. So what do we need to do if the opposite is met? Do winner. Repair. Uh, okay. And then else. Oh, awesome. You just started CS50X. That's great. I will try to catch you with your video. Yeah, no worries. Take your time with it. I'll be going on for the next couple of weeks, continuing on with the course. Feel free to use my my past streams, or even the condensed recording versions if you don't want to watch the full, with all the chats and stuff. You can watch the condensed versions and just see me taking my notes live and stuff. So yeah, watch those videos. Those are great. Awesome, Dominguez. You have to let me know how it goes. This is definitely really hard right here. This part. So else. You need to check for is equal to also. So else if it's equal to, so let me take it here. Oop. Add pairs. Your logic for adding pairs is good now. Just make sure you remove the else block at the end. So if a tie exists, what happens? Nothing. Alright, if a tie exists, I don't think we want to do anything, so we don't even really need to reference it. There must have been an angel by my side. Woo! All right, we're done. Oh my gosh. Oh my god. Woo! Round of applause, everybody. You got to leave a like on the video for this one. We struggled through this one big time, guys. Oh my gosh. Oop, whoops. Oh, wow. What a... This is... Honestly, this is why I have a little bit of problems with CS50, is because, you know, in my opinion, I really think that I've been programming for 6 months. I've already completed Harvard CS50P. I was able to fly through the first couple of weeks of this course. And then all of a sudden, a programmer with 6 months of experience and already completed courses and projects on their own gets stuck for an entire day on one of the problems. Now, does that like raise a red flag? In my opinion, yeah, right. If you have a programmer of my level, 6 months, give or take, I'd say maybe if you want to relate it to like the average programmer, you could say like maybe like 8 to 9 months. Like you could factor me down like a 30% factor because I've been doing it every day. So if you wanted to make it to like an everyday person, you could say you can maybe make it to like 9 months to a year, right? If you want to factor it to an everyday person. So an everyday programmer that's been programming for 9 months to a year got tripped up on the understanding the actual verbiage of the problem. In my opinion, I just think it's a pretty poor problem. Like yes, it's a good problem in terms of like it makes you think about stuff, but did I really understand what I was doing as I was trying to solve this and I was using the debugger? Like, not really. Like, I was just kind of like, honestly, just kind of like guessing, trying to get through it. Now, is that just a testament that maybe I'm not on the level yet? Maybe. But you have to keep in mind that this is week 3 of a beginner course, right? So that's kind of the gripes that I've been trying to convey to other beginners with like Harvard CS50P. Even then, there was a couple of problems that's on there that were a little bit difficult. Nothing to this level, but I still had gaps in that course that I had to fill in with this because it required me to use various fundamentals that you have to. It just this is my gripe with CS50. Levi says going through the motion. What do you mean, Levi? Going through the motions? Ryan says, I'm thinking about jumping ship to CS50P. Well, don't get discouraged, Ryan. I really think, like they say, that this one is the optional super, super hard version of, like they said in their, where did that go? What the heck? Why is my, ugh. Stuff is so troll. Mac OS has just so many bugs with its Safari windows. It's really bad. The new update for when they added in when Microsoft's patent ran out for like the rectangular spacing, whatever. It's been just terrible from then. Anybody else had that experience with Mac OS and the partitioning of Windows is just absolutely terrible. So many bugs. So yeah, this is feeling very, very, very comfortable. So, even me having programmed for 6 to 7 months in relation to other people, we'll say, we'll give like a 30% factor, so we'll say like 9 to 12 months, right? For the average programmer, really struggled through this one. So, thanks everybody. Thanks for the support, everybody. Appreciate the W's in chat. You guys are awesome. Thank you so much. I'll throw you guys some hundreds here. Throwing you guys some hundreds. Come on, let me mass click here. Ooh, I'll show you. Throwing you guys hundreds. There we go. Congrats, that's considered one of the hard, if not the hardest problem in the entirety of CS50, so it doesn't get any more difficult than this. Yeah, I really to throw you two-dimensional arrays at week three, it just seems kind of funny. I think sometimes the problem doesn't stick with the lecture. That's what I noticed about CS50P as well. This is normal as someone who's done college level courses in CS from undergrad to grad. Got you. Yeah, Levi. Hey Ray, did you pay for the certificate? No, if you guys are gonna take CS50 alongside me, I highly suggest just doing the free certificate. There is no difference in like credibility or claim, whatever, in content between the free and the paid certificate version. The only thing is that you can technically, through like copyright and whatnot, provide that certificate on like a resume or something, but even then, it doesn't really show much validity in terms of your actual skill set. Yeah, I think it's more of just like a personal thing. It doesn't really provide you much in terms of an actual like accreditation with like an institution, like at like a work or anything. Like so, again, the in my opinion, the free version does just as much as the paid version in terms of real world application. So the just do the free. There's no point in paying. Yeah, Mahan, I got you. So I mean, we definitely learned some stuff going through this, right? We definitely learned how to do these nested for loops to manage and access two-dimensional arrays. I got a lot of practice with that. So yes, we did learn some stuff. We learned how to, manage these two-dimensional arrays and access them. Did we learn about all of the fundamentals pertaining to this specific problem with candidates and with winners and losers and stuff? Maybe not really, but it was we got a general, we did learn some stuff on that superficial level, but we do need to kind of dive deeper into these functions and actually see what we did on each level. Now, I did write the vote function, the record preferences function, the and the add pairs function by myself. But what I got stuck on was the sort pairs, the lock pairs, the is cycle custom function, and then obviously the print. Those are the those functions I got stuck on. We did have errors, like obviously I had I in here instead of rank, and a rank out front instead of I. So I did have errors here and there. I wasn't checking the other condition here, but yeah. Some problems are going to be tricky. Some projects will be easy. You'll fly through. Gotcha. A certificate at this level might not even move the needle in terms of resume, to be honest. I'm just recommending strong portfolio and strong prep through the elite code and technical interviews. Yes, exactly, Tim. That's exactly my purpose was is that this is kind of attributed to like a freshman level course, and you're not even really a part of Harvard itself. It's just independent. So the certificate, honestly, in my opinion, holds no actual real world merit for justification of skills. So if and I mean if someone really tried hard enough, they could just copy all these answers, right? And so there is no actual credibility to the certificate on the individual basis. So it is completely just a independent goal, right? To complete. Hey, Insomniac, welcome in. Thank you so much for Levi for coming in. You have a good night. I appreciate you for stopping by and helping out through my struggles. And thank you guys so much. I am really trying to convey a beginner's point of view. If I sit here and I struggle and I look, dumb, I really don't care because I'm just trying to be authentic. I think there's a lot of people on YouTube that use the power of editing to their advantage where they'll, just chop up clips of them learning, and then it looks like they've gained all this information within 10 minutes, when in reality the behind the scenes of those videos and those live streams were hours and hours and hours of grueling work, or they just copied, right? So I'm trying to my best to convey an authentic beginner point of view or perspective when going through these courses and problems for the first time. I'm doing them live with you. I'm chatting with you live doing them. I'm going through trying different options, different angles, debugging over and over and over again. And if it takes me some time and I struggle through it, I struggle through it. That's just what in reality is this truly is. So if that's something that you're interested in, you enjoy this, feel free to follow along with me here. Thank you guys so much for joining. We have a Discord linked in the description below where I've compiled all of my resources. So if you want my my solutions to my problem sets from CS50X or CS50P, my current live running notes for these these courses where we have notes that we've been taking live in Markdown format. So really cool like clean formatting for these notes that you can get all the practice code that David does in the lectures, right? And then also on the channel, we're watching the streams, re-uploading the lectures in condensed versions that for my like kind of reactions and live note taking. And so we're just really trying to capture that 100% beginner authenticity and show that what this would be realistically like and how much time someone could or potentially put into this. Now I do put in a lot of time. I've been streaming every day for the past two, almost coming up on about 3 months now. It seems like we're moving up towards. So we just been that just kind of goes to show to prove that we've been growing quite rapidly in just our knowledge. We're getting faster at coding. I can really see that I can spot my errors a lot faster in terms of when I'm given the error message in the terminal. I can kind of deduce what it means. I can spot potential bugs before they arise. I can predict like user inputs a lot better in edge cases in my own projects, right? So we work on our small business manager project that we've been writing live on stream for the past couple of months. So really, really cool progress we've got going on so far. But I thank you guys for stopping by and joining me tonight or today. I'll stay in chat just for a little bit longer and answer any questions you guys might have. But I have to pick up my girlfriend here at 5 p.m. from a work event that she has. So I got to head out here in just a second to make sure I get down there in time. But I might come back on and stream just some live coding later today. But this officially wraps up week 3 of Harvard CS50X. So awesome! Congratulations! Give yourselves a round of applause if you are doing it alongside me. We have done, we started January 1st and we completed week 0, 1, 2, and 3 by the end of January. So which is really, really great because we're right on track with the course. Then we completed the first 4 weeks in the first 4 weeks of the year. So we're right on track with the course to complete it, in the allotted time. Maybe we can try to keep leveling up and try to beat it by like a week or so if we can. But we might not be able to because the final project will probably hold us up for a few weeks to finish. But yeah, it's just going to show you guys that this stuff is hard, but we are human, and if I can do it, you can do it. I really attest that. I'm no different than anybody else in my opinion. Yeah, I have a college degree in biology and chemistry, but I did a similar kind of amount of work I had to do for that degree. So I'm just kind of showing you guys like what it would take, to maybe potentially be successful or find success on an individual level from a beginner's perspective. So yeah, thank you guys so much for joining me today. I will post in the Discord an announcement for if we go live later this afternoon for just a live coding session working on some practice problems, whether it be Leet Code or the Small Business Manager, everything like that. Really quickly though, I wanted to show you guys. Yesterday I worked with a fellow subscriber in the channel, Mahan. Thank you, shout out to you, Mahan. You're awesome. Thank you guys for joining me here. We have, hold on, let me pull up my Leet Code. Hope it's working. Hold on, guys, sorry. Let me, Leet Code. I hate Apple computers. I don't hate them, but I love them, but they're just so buggy with these windows. It's really terrible. quickly, guys. All right, I wanted to show you guys here. So we completed, me and Mahan yesterday, he helped me with some problems here. Let's filter them out. Cool. So yeah, yesterday I completed with him the remove duplicates from a sorted array. Um, right? So this was my submission that we did yesterday for this problem. Yeah, so this was my solution. So to remove duplicates, what we did was we have a left pointer that starts at 0. We have a right pointer that starts one place further than the left pointer. If the left pointer equals the right pointer, or if the left pointer does not equal the right pointer, then we're going to increase the left pointer by 1, um, right? And then, wait, hold on. What did we do here, Mahan? Can't see. Oh, whoops, my bad. Right, so we did left pointer equals 0 for right in the range of 1 to length of numbers. If the numbers left, so numbers at index 0 and the numbers at index 1 is not equal to each other, we will go ahead and do a swap, right, for the left plus 1, which basically means the right, becomes the right, and the right becomes left plus 1. And then we increase left, and at the end of this we return. So this problem specifically wanted some additional things, like it wanted the array to be in to have the array modified in place and then return a k value. So this one was a little bit funky, but let's go back and try to look at some of the other ones. We did majority element here. So in majority element, we're asked, given an array of numbers of size n, return the majority element. So in this one, right, our first kind of pass was, should we use a hash map or not? But then Mahan had a good idea of using kind of like a count. Now, you have to think about this kind of creatively, is if you come across a number like in a stack that you've already seen before, you can increase the count, right? But if you come across a number that is new, you would reduce the count. So if you have a positive count at the end of the iteration, then you have a number that was a majority, basically. So it's kind of like having a queue or a stack in a sense, but not really. If you think about it, it's like you push onto the stack a number, you take it off if you don't. So if you have an element on the stack, that means that you have technically a majority element, and that you can return the current element that is being iterated over, because the most current update will, if you have a majority element, will be that current element that was last updated. So this one was really kind of cool to solve, and we got a pretty good score on it too. Let's go back here really quick. Let's check on. We have a move zeros problem here. So this one, given an integer array of numbers, move all the zeros to the end while maintaining relative order. Note that you must do this in place, not make a copy. So I had two submissions here. My first submission was using was iterating over the back of the list. So if you start from the back of the array and then pop off numbers that are equal to 0 from the back, you don't have to actually shift, right? You don't actually have to shift, but this one's a little bit slower because now think about this, in the best case scenario, you still have to run an O of n time, because you still do pops no matter what to those zeros and append them to the back. even if they were already at the end. So you would still have a worst case running time of O of n, um, at least for that slice of zeros, right? Um, Change CPP to Python in code tab so you can see your code in the editor. Oh, there. Change CPP to Python. Not sure what you mean. Yeah, so, but then I had a second attempt here with Mahan where um, we did a similar approach to that one problem. We have a left pointer at 0, a right pointer starting at one index place higher than the left pointer. If the right pointer is equal to a 0, we will just swap and continue to kind of do like a bubble swap through one iteration um, in O of n time. So we were able to solve it a little bit faster here as well. Um, I'm trying to go down the same path, trying to learn how to code. Any tips? I already know some HTML, CSS, JavaScript, and general knowledge of data structures. I don't know. I think my logic is too good. Yeah, hey, Talika, thanks so much for coming. I appreciate you for joining me. For just a little background, I graduated back in 2021 with a degree in human biology and a minor in chemistry, and I've been doing a live, like, video series, live stream series of my entire progress. Teaching myself from scratch, various programming languages like Python and computer science. So I started with Harvard CS50P. That was about 6 months ago at the beginning of the summer of 2024. I solidified that course with reading live on the channel Python Crash Course. We read the entire book live on channel. I have all my past streams of me reading this book, and we completed live on the channel all of the in-text practice problems. I currently am going back through the book and uploading, solutions to those practice problems for other beginners out there that might want, some video solutions to those. Explaining some of the, some simple basic, Python syntax and use cases. But so I solidified the Harvard CS50P with this book, and then I started, working on an independent project. So I completed a task tracker application project where, you can, it's on my GitHub. I wrote the entire project live on my channel, and now we're writing a small business manager project live on my channel. So like I say, everything I'm doing it with an authentic point of view from my perspective, a beginner perspective, and I'm trying my best to do everything live here for you guys. And so yeah, it's awesome. Do you have any tips? Yeah, I would highly suggest just following onto the channel with me. I have a Discord linked below where I have compiled all of my resources from all the books to all the problems that you see to everything I do on the channel is kind of basically compiled into my Discord. I'll show you a little preview here. Yeah, so I have like, the various books that I'm reading, Python Crash Course into categories of Python, HTML, CSS, C, Swift, Harvard CS50. Eventually, we're going to get into some mathematics and continue on with our math learning journey. Currently, I've learned up to Calculus 1 in college, but we need to go further. We have a project showcase where a lot of members have showcased their personal projects. So we have over 300 members in the Discord, and it's a really great place to be. And so you can join that and get access to everything there, and continue following along with me here. But I would highly suggest, if you're new and wanting to start out, is I'm currently taking Harvard CS50X live on the channel. We were just finished week 3 literally today. We finished week 3 on algorithms. So tomorrow we're going to be working on week 4, watching the lecture tomorrow. So if you're wanting an opportunity to kind of start a beginner course here, I've just kind of begun here in January this course, and this would be a great opportunity to try to catch up with me, at least try to complete it alongside me, because I'm providing you all of my answers, all of my thoughts, my thinking, my notes. I'm even providing you my live watch alongs to the lectures and recordings. So it really will be a perfect one-stop shop area for beginners to really have like a camaraderie aspect and networking aspect when working along through these courses and independent studying. So I'm really trying to create a peer-to-peer environment as if we were like friends, just booked a study room together in the library and we were just working on our homework. So, yeah, awesome. Yeah, it sounds like you're hyped for math. That sounds good. Yeah, I have a lot of people that seem to be interested in the math. We need to start that soon enough, but I have a lot of projects going on. So maybe once we finish Harvard CS50X at the end of maybe February, I think is by the time we'll probably be done with the course, we can jump into some math courses and continue on into Calculus 2, 3, and linear algebra and things like that. But yeah, so tomorrow we'll go over we'll watch the lecture on week 4 on memory. So yeah, we'll continue on that one. I'll post into my Discord an updated thread for the CS50X course here. So I've been posting live threads. For instance, on week 2, I have just all of the things that we captured and accomplished, all of the, a link to the GitHub repo with all my notes. I have links to the live streams and the recordings. Everything is provided for you here, so it's a great place to be. Um, I've been yapping for a little bit, so sorry. If you guys have any questions, feel free to shoot them over here. But before I end the stream, I've got to kind of wrap things up here shortly to go pick up my girlfriend from her work event. Um, so if you guys have any just questions, feel free to let me know before I wrap things up here. But I thank you guys so much for joining me. Today we completed Harvard CS50X Week 3 on algorithms. We we really struggled through this Tideman problem. This was typically known as the hardest problem in the entire CS50 catalog. And so we were able to, complete it with, a lot of help from the debugger and everything with the final remaining few functions that it needed. So that just goes to show you that we got a lot to learn, and I'm excited to continue learning. But even if we struggle, that's okay. That's just what the reality of things are, and I'm trying to, show that to you guys. So follow along to the channel if you guys enjoyed the stream and enjoy, what I'm doing. Feel free to get a thumbs up. It really helps YouTube to keep promoting the stream and get new people in here and growing our community. And so, anyways, guys, thanks so much for joining me. I'll post an announcement in the Discord if I go live later this evening for some live coding sessions, just to be chill and just do some live work on the projects because we went through these these grueling practice problems today. But yeah, all right. I'll talk to you guys later. Thanks so much for joining tonight or today. I'll see you guys a little bit later.